Okay, let us solve the 21st question. The 21st question says, a medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. Okay. So let us first draw the diagram of this question. The diagram of this question number 21. The diagram for this question is like this. Okay, it's like this. This is a capsule, this is a medical capsule, and this capsule has the diameter as 5 mm, 5 millimeters. Okay, and the length of this capsule, the total length of this capsule is 14 millimeters. So this is the length. Now it says that this capsule is made up of a cylinder and there are two hemispheres stuck at the ends of this cylinder. So I can divide this figure into three parts. Okay, into three parts. Like this, where this part, this is the center of this hemisphere, this is a hemisphere. Okay, this middle portion is a cylinder and this end is also a hemisphere, and let us say this is the midpoint of this hemisphere. Now we need to determine the area, the surface area of this particular capsule. Now how to determine the surface area? I can see that if I take a cylinder and at the two ends I stuck two hemisphere, I can see this end of the cylinder. At this end of the cylinder, this is the cylinder, and I have pasted a hemisphere at the end of this cylinder. So what is happening? I am joining the base of the hemisphere and the base of the cylinder together. So what I can see is the base of both the hemisphere and the cylinder is covered inside. Okay, that is, the base is hidden. So at this point I can see that in this capsule the only part which is open, the only surface of this this cylinder and this hemisphere is open to the atmosphere or open to the outside world is this surface, that is the lateral surface, and for this hemisphere also the lateral surface. The base surface of capsule, the base surface of hemisphere and the base surface of cylinder are stuck to each other. Then coming to this portion, this hemisphere, you can see this hemisphere and this cylinder, the base of this hemisphere and base of this cylinder, the second end of this cylinder are also stuck to each other. So what I can see is the base of this hemisphere is gone inside and this base of this cylinder is also gone inside. So at the outside world, at the atmosphere, I can only see the curved surface area of this cylinder and the curved surface area of this hemisphere. So what I can say is, if I want to color this particular capsule, the area on which I can color this capsule includes three parts. The first part is the curved surface area of cylinder. Okay. Second part is curved surface area of this hemisphere at one end and curved surface area of this hemisphere at the other end. Okay. So total surface area of capsule includes three things. The first thing is curved surface area of hemisphere in left side. Second, curved surface area of cylinder. Then third, curved surface area of hemisphere in the right hand side. Okay, in the right. So these are the three curved surface area that we can see. This is the first curved surface area, this is included. This is the curved surface area of cylinder, this is included. This curved surface area is also included. Remember, the base of not even the base of this cylinder or the hemisphere are included in the total surface area, because you can see the base are stuck to each other. So base छुप गए, because base एक दूसरे से चिपक गए हैं. Okay. So for that, my task is to determine three curved surface areas. What is the curved surface area of left hemisphere? Curved surface area of left hemisphere will be 2 pi r square. Now curved surface area of cylinder, it will be 2 pi r h, and curved surface area of right side hemisphere which is at the right side, it is again 2 pi r square. This is what we can see. Now moving further, for curved surface or of cylinder or hemisphere, I need radius and height of cylinder. So what is the radius of this cylinder? What is the radius of this capsule? This diameter is 5 mm, so the radius of this capsule is 5 by 2 mm. Okay, 5 by 2 millimeter. This is the radius of the capsule. Now further, at the two ends, this length, since this is the hemisphere, so radius is 5 by 2, so this is also radius, which is 5 by 2 mm. Okay, and also at this end, I can see this is the radius, which is again 5 by 2 mm. So at both the ends of this capsule, I can see that this length is 5 by 2, this length is 5 by 2. So what is the height, what is the length of this cylinder in between? See, this is 14. See, this is 14. Okay, and this is 5 by 2, this is 5 by 2. So in all, from 14 I can subtract total 5 by 2 plus 5 by 2, that is 5. So the length of this cylinder in between is 14 minus 5, that is 9 millimeters. Okay, so curved surface area, the first curved surface area will be 2 into pi into r is 5 by 2 square. Okay, second curved surface area of cylinder is 2 pi r h, so it is 2 into pi into r is 5 by 2 into h is 9. Okay, then third curved surface area, this will be 2 into pi into r is 5 by 2 and the square. Okay, so this is the total surface area. So in total surface area of capsule will be equals to what? It will be 2 pi r square, 2 pi r square, 4, this is will be 4 pi r square, 4 pi into 5 by 2 square, plus this will be 2 pi and this is 9, so I can cancel 2 and 2, this will give you 9 5s of 45, so 45 pi. Okay, so this will give you 25 pi plus 45 pi in millimeter square. Okay, because the unit that we are using is millimeter, so answer should be in millimeter square. So in this way I can get the area of the capsule that is open to the atmosphere. This much area of the capsule is open to the atmosphere. Okay, so this is the solution for question number 21. So this question is again interesting question. The only complexity is to calculate the length of cylinder in between. Okay, the length of cylinder which is in between of this capsule. So this is the 21st question. You can note this, then we will continue. Okay, so let us now solve question number 22 from the practice sheet. Question number 22 says a gulab jamun contains sugar syrup up to about 30% of its volume. Okay, so it says that the gulab jamun, you might have had gulab jamun at festive season. So gulab jamun contains sugar syrup up to about 30% of its volume. Okay, find approximately how much syrup would be found in 45 gulab jamuns, each shaped like cylinder with two hemispherical ends with length 5 centimeter and the diameter as 2.8 centimeters. Okay, so what it says is that the gulab jamun contain sugar syrup up to 30%, okay, of about 30% of its volume. Now volume means, if I say that, let us say the volume of one gulab jamun is 100 ml, okay, the volume of one gulab jamun is 100 ml, so it means that gulab jamun should contain 30% of its volume, that is, if I calculate 30% of 100 ml, it is 30 ml, that is each gulab jamun will contain 30 ml of syrup, okay, the sweetening syrup. So what it says is approximately how much syrup would be found in 45 gulab jamuns if each gulab jamun is cylindrical in shape and hemispherical ends of that gulab jamun with length as 5 centimeter and diameter as 2.8 centimeters. So let us first draw the diagram. Question number 22. If I try to draw the diagram of this gulab jamun, it will be like this. It will be a cylinder, and at the ends of the cylinder we will going to have two hemispherical surfaces like this. This is one surface and this is another surface. So this is somehow is the shape of gulab jamun. It says the length of this gulab jamun is 5 centimeters. Okay, the length of this gulab jamun is 5 centimeters and the diameter is 2.8. So diameter means this length. This length is 2.8 centimeters. So if diameter is 2.8, then what is the radius? The radius will be 1.4 centimeters. This is the radius, 1.4 centimeters. Okay. Now our task is to calculate how much syrup is contained in 45 gulab jamuns. So for that, let us calculate the syrup contained in one gulab jamun and then multiply it by 45. Okay. Now for calculating the syrup content in one gulab jamun, what is needed, what is required? It says that the syrup is 30% of volume of gulab jamun. So what it says is sugar syrup is equals to what? It's 30% of volume of gulab jamun. Now since sugar syrup is 30% of total volume of gulab jamun, my task is to calculate the volume of gulab jamun, then only I will get the content of syrup. Okay, try to understand the approach. My task is to calculate the sugar syrup in 45 gulab jamuns. For that, I can calculate the syrup in one gulab jamun and multiply it by 45. Then to calculate the syrup in one gulab jamun, I can see a relation between the sugar syrup and the volume of gulab jamun, that is 30% of volume of gulab jamun is the content of sugar syrup. So my task is finally to calculate the volume of each gulab jamun. Now how can I calculate the volume of each gulab jamun? I can see that gulab jamun is made up of three different solid figures. One is a cylinder and two hemispheres at the two different ends. So to calculate the volume of this gulab jamun, my task is to calculate the volume of these three different solid figures. The first solid figure is this one. This is the first solid figure. Okay. Then this is the second solid figure. This is the first, this is the second, and this is the third. So what I need to do is, I can write total volume of one gulab jamun is equals to what? Volume of first figure plus volume of second figure plus volume of third figure, that is volume of first hemisphere plus volume of second hemisphere plus volume of, you can see this is first hemisphere, this is second, and this is the cylinder. So plus volume of cylinder. Okay. Now what is the volume of hemisphere? We have understood the formula, we have already noted down the formula. The volume of one hemisphere is 2 by 3 pi r cube, okay, plus volume of second hemisphere is again 2 by 3 pi r cube, plus volume of cylinder is pi r square h. So pi r square h. Now what is the height of this cylinder? Height of this cylinder is, let us calculate the height. I can see for this hemisphere the radius is 1.4. So this length is 1.4 centimeters, and similarly at this end this length is again 1.4 centimeters. So in all this is 1.4, this is 1.4. So the length of this cylinder in between this length, this should be 5 minus 2 times of 1.4, that is 2.8. So for that subtract 3 from this 5, it will be 2, and then add 0.2, so it will be 2.2. So this is 2.2 centimeters represent the height of the cylinder. Now to calculate the volume, it is 2 by 3 pi. Now what is radius of this hemisphere? It is, we have calculated, it is 1.4, and these two hemispheres are symmetrical. So this is 1.4 cube plus 2 by 3 pi into 1.4 cube plus pi into radius of this hemisphere is 1.4, sorry, cylinder is 1.4 square into h. H is what? We have just calculated the height of cylinder, or in this case the length of cylinder, it is 2.2. So this is 2.2. So this will give you 4 by 3 pi 1.4 whole cube plus pi 1.4 square into 2.2. This is the volume of one gulab jamun in centimeter cube. Okay, this is the volume of one gulab jamun. Now we have just calculated the volume of one gulab jamun. So what is the volume of 45 gulab jamuns? So volume of 45 gulab jamuns is equals to 45 times this volume, 4 by 3 pi 1.4 cube plus pi into 1.4 square into 2.2, okay, in centimeter cube. This is the volume of 45 gulab jamuns. Now, and just now I have written the relation between the content of sugar and the volume of gulab jamun, that is syrup is 30% of gulab jamun, volume of gulab jamun. So sugar content or sugar syrup in 45 gulab jamun is equals to 30% of this value, okay, 30% of this value, that is 30% of 45 to the bracket 4 by 3 pi 1.4 cube plus pi times 1.4 square into 2.2, and this is the volume in centimeter cube. But now since syrup is a liquid, so I do not want to write the volume of syrup in centimeter cube. I can write it in milliliters or liters, and for that we have a relation that 1 liter is equals to 1000 centimeter cube. So if 1 liter is 1000 centimeter cube, how many milliliters are there in 1 liter? 1 liter is 1000 milliliters, which is equals to 1000 centimeter cube, which implies I can see this 1000 and 1000 get cancelled, and 1 ml is equals to 1 centimeter cube. So I want to write the volume of this sugar syrup in ml, that is in milliliters or liters, because this is a liquid. Okay, so in place of centimeter I can use this unit, I can use this conversion, that 1 ml is 1 centimeter cube. So in place of this centimeter cube I can write milliliters. So my final volume of this sugar syrup will be 30 upon 100 into 45 to the bracket 4 by 3 pi into 1.4 cube plus pi into 1.4 square into 2.2, and this whole volume in this complete volume in milliliters. Okay, so just calculate the value of this volume and you will get the sugar content in 45 gulab jamun. So this is the solution for question number 22. Okay, so you can note this, then we will continue.